Hello and welcome to section 15. In this video we're going to introduce signal modeling and work through example 1. So in the last section, section 14, we looked at transient circuits, so specifically circuits that discharge. So they had some initial voltage or current and then they discharged down to zero, and we wanted to model that discharge curve. So how long does it take to discharge? In the future sections, so sections 16 and 17, we're going to look at circuits that charge. So things that we turn on are things that we turn on and off and on and off. In order to model that, we need a signal that can be turned on and turned off. So we take a slight detour and we look at signal modeling so that we can model those functions before applying them to our transient analysis. So to model our signals, we're going to use 3 singularity functions. So singularity functions are functions that are discontinuous. The first being the unit impulse, the next being the unit step, and the unit ramp. So I'll just you can read this at your own leisure. All right. So the unit impulse function, let's get that lined up, there we go. So the unit impulse, if we have t and say this is t equals 0, then what will happen is our impulse function will occur at time equals 0, and it'll be as tall as it needs to be, actually infinitely tall. But the important characteristic of it for a unit impulse is it has an area equal to 1. So the impulse function looks something like t. So it's kind of like an 8, but missing that last little chunk. This is also called the delta function. So if I integrate this over time, I get the next function, which is the step function. So the step function, again, I have t, I'll have time equals 0. And so what will happen is that we'll be coming along, and then all of a sudden, we will jump because that impulse will be applied, and then we'll head over. So this, if it is a unit step function, will have a magnitude equal to 1. So the step function is the one we use the most, and it is u of t. And then if we integrate the step function, we get the ramp function. You can keep going down, but we don't go any farther than the ramp for this class. So the ramp function, again, we can integrate the step function over t. And so what will happen is we don't accumulate any area until we get to 0. And then what will happen is this will then have a constant slope. That slope, if it is a unit ramp function, the slope will be equal to 1. So it'll rise and run will equal to 1. And so that is r of t. We can also write this as t times u of t. So like I said, u of t, the step function, is the more common form that you're going to see. So example 1, so I'll just bring it up on the screen real quick so you can see it. Example 1 is going to ask us if we can write a signal function for I of t, given that it starts that it's 0 before 0 and 12 after 0. So this is discontinuous. All right. So example 1. So we have the following information. I of t is equal to, so it is 0 for all time less than 0, and it is 12 for all time greater than 0. And what happens at 0 isn't super important. You could assume that it's halfway between. You could say it's discontinuous. Like, it's not a really big deal. So this is how you might write it, like a piecewise. What we're going to do is we're going to write this with a single line. We're going to say that I of t is equal to, so this, if we drew the, I guess before I do this, let's just draw what this looks like. So we have t, we have 0, and so we're just kind of cruising along here at 0 before we get to 0, and then once we get to 0, we're going to be up here. So the magnitude of this, sorry, magnitude is equal to 12 amps. So this, and if you wanted to, you could dash this, you could make it a line. Like normally we're just going to make it look like a step function because it is a step function. So step function is u of t, but that's only equal to 1. So if I want to make the magnitude 12, then all we're going to do is just multiply the step function by 12. And that is your answer. So I of t equal to 12 u of t. And I guess amps would be the units on that. All right. If you have any questions, feel free to contact me.